Have you ever opened an Android application in JDEX and noticed some logic that completely blocks you during dynamic analysis? Things like root detection, ADB or emulator checks, or even native site protections. And you thought to yourself, if I could only modify or bypass this logic. That's exactly where Frida comes in. In this video we are going to talk about Frida, one of the most powerful tools for Android reverse engineering and dynamic analysis. This is a beginner-friendly video, so you don't need to have any prior Frida experience. We will start from the zero and cover what Frida is and why it is so important, how Frida works conceptually, how to install and set up it, and finally some simple and medium level real world examples. I know that many beginners think that Frida is too complicated to use. I was thinking the same when I was starting, but I want to assure you that Frida is much easier to use than you think, and I will prove it in this video. If you already know tools like JDEX, APK Tool, Burp Suite, Frida is the next logical step in your Android reverse engineering journey. So far, most beginner Android reverse engineers focusing on static analysis. You to compile APK, read Java code, inspect resources, and so on. But static analysis has its limitations. And that's where the dynamic instrumentation becomes necessary. Frida is a dynamic instrumentation toolkit. In simple words, Frida allows you to inject your own JavaScript code into a running app to influence its behavior without modifying the APK itself. That means that you can override, bypass, or rewrite nearly any part of app's logic. At a high level, Frida consists of two main parts: a Frida server running on Android device or emulator, and a Frida client running on your PC. The client sends JavaScript code to the server, and server injects this logic to the running application. The JavaScript code can interact with Java methods, native functions, and Android framework APIs. Now when you understand what Frida is and why it is so important, let's move to the practical side. In the next section we will install Frida, set up the environment, and ensure that everything works correctly before touching the real-world examples. Please note that all the next steps should be followed very carefully, because even the smallest mistake can cause errors that are very hard to debug. To install Frida, you first need to have Python installed on your PC, because we will use pip command. Once Python is installed, open terminal and run pip install frida-tools. In my case, Frida is already installed, but on your machine you will see installation logs. To verify that Frida was installed correctly, run frida-version. If everything works fine, this command will simply print the current Frida version. At this point, Frida is installed on your PC, but that's only half of the setup. Now we need to install Frida Server on the Android device or emulator. Open your browser and simply search for Frida Server. The first result should be Frida's official GitHub repository. Open it. On the GitHub page, go to the releases section. And here is an important detail. The Frida server version must match the version of Frida installed on your PC. In my case, I'm using Frida version 17.2.11, so I open the assets for that exact release. Inside the release assets, you will see multiple Frida servers binaries, each one built for a different CPU architecture. Android devices and emulators can use different architectures, so we need to be sure to install the correct one. One way to check the architecture is by running command adb shell getprop raw.product.cpu.abi. This command prints in the terminal the Android device architecture. Another and even easier way to check it is by opening Android Studio, going to the device manager and checking the device details there. In my case, Emulator uses 8664, so I download the Frida server for that architecture and extract it. And one very important thing to mention: Frida requires root access on the Android device. In this video, I'm using Android Emulator with non-production build, so I can easily get root access by running adb root command. If you are using physical device, make sure it is rooted. You can use, for example, Magisk. Now we need to push Frida server binary to the device. We run the following command: adb push Frida server location /data/local/tmp. Next, we need to get root access, so I simply run adb root, and then I enter the device shell by running command adb shell. Then we have to make the server executable. We run the command chmod 755 /data/local/tmp/Frida server. And finally, we need to start the Frida server by running command ./data/local/tmp/Frida server. At this point, Frida server is running. Don't close this terminal window because it will stop Frida server. To continue using adb commands, we need to open new terminal window. And now let's verify that Frida is working correctly by running the command frida-ps-u. If everything is set up properly, this command will list all processes running on Android device. If this command doesn't work, pause the video and double check that Frida server version matches your local Frida version, that you downloaded correct architecture, and that the Frida server is actually running. And one more important thing to know: If you stop the Frida server, you have to start it again manually. That means repeating all the things we just made for the emulator. Now I want to share a small life hack that can save you a lot of time when you work with Frida regularly. I personally keep the simple text file where I have written down all the commands needed to start the Frida server. In this way, I don't have to retype long paths, remember all the commands, and worry about small typos. All I do is copy and paste all the commands one by one. Let me show you how fast it actually is. First, I'll stop the currently running Frida server. Now I'll open a new terminal window and simply copy and paste all the commands from my text file. Getting root access, pushing the Frida server, entering the shell, making the server executable, and starting it. And that's it, Frida server is running again. Let's verify again that everything is working. I open new terminal window and run frida-ps-u. And as you see, it really works again, just in few seconds. I personally use this method every time I work with Frida. It saves a lot of time and makes the setup process fast and reliable. Just keep one thing in mind. The path to the Frida server file must remain the same all the time on your PC. If you move or rename your Frida server file, the path on your text file will be broken, and you will need to update that. Now that Frida is installed and working correctly, we can use it in practice. In the next section, we will start with the simplest Frida examples and we'll slowly go to the more advanced ones. For our first example, we will keep things as simple as possible. The app you see on the screen, open in JDEX, is a very basic Android application. It has just one activity and a single text view in the middle of screen that says Hello World. There is no special logic here, and that is intentional. Before we hook methods or modify the behavior, we want to make sure that Frida can actually attach to the application and execute the script. So in this example, we won't change anything in the app yet. Our Frida script will just do one thing: print a message to the terminal when it gets injected to the app's process. As I mentioned earlier, a Frida script is a simple JavaScript code that gets injected to the application at runtime. You can write this code in any text editor, but I personally prefer Visual Studio Code. I open it, create a new file, and now we can start writing our script. The first thing we write is java.perform open parentheses, function open and close parentheses, and curly brace. This is the entry point where our code is executed inside the application's Java runtime. Everything we want Frida to do will be written in this function. Now inside it, I add a simple log statement. I write console.log, and as an argument I can pass any string, so I will write Frida attached successfully. And then I close the function. This line will print the message to the terminal so that we can confirm that Frida attached to the process successfully. Now I save this script as a .js file on my desktop. Next, let's launch our test application on the device. First, I launch it normally without Frida so you can see that it works as expected. So you can see it works and that it's a simple application doing actually nothing. Now let's launch the same application using Frida. To do that, I use the following command: frida-u-f apps package name, so I go to the JDEX and copy the apps package name and paste it, -l, and script location. So I just drag and drop our script from the desktop to the terminal and its location is pasted automatically. Then I press enter and as you can see the app is relaunched. And in the terminal we can see our message, Frida attached successfully. This confirms that our Frida was injected to the application and executed correctly. From now on, we will use the same structure, but instead of simply printing the message, we will hook methods and modify the app's behavior. Before we continue, I want to clarify one important thing. When you are done working with Frida script, you should always stop it correctly. If you just close application when Frida script is attached, it will be terminated forcefully and can lead to some issues. For example, Frida may become unstable or Emulator will be needing a restart. To stop a Frida script correctly, go to the terminal where Frida is running and press Ctrl+C and then type exit. This way the script execution is finished correctly and you avoid unnecessary issues. Now that we confirm that Frida can attach to the application, let's do something more interesting. In the next example, we will hook onCreate method of the main activity. OnCreate method is always called when the activity is created, so it's perfect place to start. Now instead of printing log message to the terminal, we will print it directly to the Android logcat. This will clearly show that our Frida script is executing inside the application, not just in the terminal. The application itself will be the same as in the first example, so let's move directly to Frida script. We will reuse the same script file, there is no need to create a new one. The first thing we need is a reference to the activity that contains the method we want to hook. I create variable for it. I write var MainActivity equals to java.use, and now we have to specify the full class path, including the apps package name. I go to the JDEX, copy the apps package name, paste it, and after that I write the activity name, so in this case MainActivity. Now we use this MainActivity reference to override its onCreate method. I write MainActivity.onCreate.overload android.os.bundle.implementation equals to function bundle. This means we are redefying the onCreate method that takes bundle as a parameter. Everything inside this function will be executed instead of the original method. Now we want to create a log message. First we get access to the Android's logging class. I write var log equals to java.use android.util.log. And then we write the log message. It should have the same structure as log in Java. I write log.d and pass Frida as the name of the log. Then as a second parameter I pass the log body. In this case it will be MainActivity.onCreate was called. And after that it's very important to call the original onCreate method, because otherwise the app's UI will not be initialized. And finally we close the script. I save the changes in the script file, and now I log Android Studio Logcat. Now I open terminal, and since neither of the application or script location changed, I simply reuse the same Frida command from the terminal history. I press the up arrow and hit enter. The app starts normally. And now in Android Studio Logcat we can see the message was created purely in the Frida script. So we successfully hooked and modified onCreate method of MainActivity without modifying or rebuilding APK. Now in the next example we will go one step further. Instead of just logging something, we will influence the app's behavior. This demo application has two main parts: an ADB checker utility class that checks whether ADB or USB debugging is enabled and returns a boolean value, and MainActivity that calls this method and displays the result on the screen. Let's launch the application as it first, without any Frida script. I launch it normally, and as you can see, it says ADB is enabled. Now let's change that. I open my Frida script file again and remove everything we don't need, so we can write clean script for this example. The first step is to get the reference to ADB checker class, the same way we did for the MainActivity before. I write var ADB checker equals to java.use, I paste the app's package name, and now I write ADB checker class name. Now we override the behavior of its method isADBEnabled. I write adbchecker.isADBEnabled.implementation equals to function, context, and curly brace. Quick reminder, I write context here because the hook function should have the same argument as the original one. Now we can write a completely new implementation. First, I will add a log message so that we can confirm that the method is actually being called in the terminal, and then I will simply return false. This means that this method will always return false now, no matter what device settings are. Now I launch the application again with Frida. And here we are, the result changes immediately. The application now shows ADB is disabled, so we successfully changed the app behavior during runtime. This simple example shows a core idea of bypassing real protections in bigger applications. Things like ADB checks, root detection, emulator detection, and so on. In real applications, these checks may be much more complex and even sometimes located in native libraries. But the concept remains the same. Find the method that controls the behavior, hook it, and override it. Now let's look at another real-world example, bypassing login screen. This demo application starts with login activity, and this is the first screen you see. And no matter what credentials you enter, it will never navigate to the next screen. This imitates the case when we don't know credentials, or the app intentionally blocks us. Let me show you. I run the application normally. Let's try to type anything, and now we press login, and it always says invalid credentials. There is no way to reach the main menu from here. Now we will bypass it using Frida. The goal is simple. When the login activity starts, meaning its onCreate method is called, we will simply jump to the next activity, main menu activity. So I return to the script as usual and remove everything we don't need. Now I first get reference to login activity. I write var login activity equals to java.use, I paste the app's package name, and I write the login activity class name. Now we need an intent reference. I write var intent equals to java.use android.content.intent. And reference to main menu activity. I write var main menu activity equals to java.use, I paste again the app's package name, and I write main menu activity class name. Then I hook onCreate method of login activity. I write login activity.onCreate.overload android.os.bundle.implementation equals to function bundle open curly brace. Inside the hook I still call the original onCreate so the activity initializes normally. I also make a log to ensure that our Frida script is running. Right after that I can create an intent. I write var intent equals to intent.new. I pass this as a parameter for context and main menu activity.class as a target class. And now we start the intent by running this.startActivity intent. And finally I call finish so the login screen is removed from the backstack. Now I launch the application through Frida, and immediately instead of staying on the login page, we are redirected to the main menu. Again, this is purely dynamic behavior change at runtime. This technique is extremely useful in real reverse engineering when the first screen blocks you from reaching another screens of the application. Now I want to show you one of the most practical and valuable Frida use cases in real Android reverse engineering. Very often Android applications store important strings in encrypted form. This can be API keys, secret endpoints, tokens, configuration files, or hidden feature flags. Sometimes the encryption looks complicated. It may use AES, custom algorithms, or even hidden keys in native libraries. Many beginners think that to extract these values, you have to fully reverse the encryption logic. But here is the important point. If the application can decrypt something, we can force it to decrypt anything for us during the runtime. Let's look at this demo application. It contains a utility class called cryptoutils with a method named complicated decryption method. This method takes an encrypted string as an input and returns the decrypted plaintext. In the main activity, the application decrypts one encrypted string normally and displays the result on the screen. So if I launch the application, we can see that decryption works correctly. The app shows the decrypted text on the screen. In this case, it is hidden encryption string. But now here is the interesting part. Inside the same activity, there is another method that is never called anywhere in the application. It is called return decrypted string, and inside it there is another encrypted string. This string is never decrypted during normal app execution. So we see the encrypted value, but we actually don't know what it means. Now our goal is simple. We want to decrypt the encrypted string without knowing the key and without re-implementing the decryption logic. So I go back to my Frida script and remove everything we don't need. Now the first step is to get the reference to cryptoutils class. I write var cryptoutils equals to java.use. I paste the app's package name and write cryptoutils class name. And then I simply call the decryption method manually. I write var result equals to cryptoutils.complicated decryption method. Now I go back to the JDEX and copy the encrypted string from the unused method, and then I return to the script and paste it as an argument to that method. And finally I print the decrypted value to the terminal using log. I write console.log, decrypted string, and the result. Now I save the script and launch the application through Frida. And as you can see, the script executes immediately. In the terminal, we get the decrypted plaintext of the hidden string. So even though this method was never called in the application, we could decrypt it using our own Frida script. And this is really useful in real-world Android reverse engineering. If your application can decrypt something, you can always force it to decrypt anything you want. Now let's move to the final example, where we will not hook the app's logic, but we will hook Android framework logic itself. Let's move back to the previous application demo, the one that checks if the IDBA is enabled. In this example previously, we bypassed this check by hooking the app's own method is IDBA enabled. This approach works, but it is fully dependent on how the application is implemented. What if application performs multiple IDB checks, or is they located in different places of the application? So now we will do something more powerful. Instead of hooking the app's method, we will hook the Android framework method that application relies on. In our case, the application calls settings.globalGetInt with the key ADB enabled. So our goal is simple. We will hook settings.globalGetInt, and whenever the key is ADB enabled, we will always return 0, meaning ADB is disabled. Before we write Frida script for this example, I want to show you something important. In real work, I nearly never write Frida scripts from scratch, especially when they start getting longer and involve Android framework methods. Instead, I use AI to speed it up. This doesn't mean you don't need to understand Frida. You still need to know what method controls the behavior, what you want to hook, and how application works. But AI is extremely useful for generating the base scripts that you can review and adjust. And this example is perfect for that. So we move to an AI tool, for example ChatGPT, and create a prompt. It's very important to clearly describe the context, so the prompt for this example looks like this. Write Frida script for Android. My application checks if ADB is enabled using settings.global.adb enabled. I want to override the Android ADB check itself so that it always returns false. We submit this prompt and the AI generates a full Frida script. It handles method overloads and returns the correct values, so in this case we can use the script as it is. Of course, keep in mind that AI can make mistakes, especially in complex applications, so always check the script yourself. So I copy the generated script, paste it to my JavaScript file and save it. Then I launch the application with this Frida script. And here we are. The application now shows ADB is disabled, and in the terminal we can see logs created by script confirming the ADB checks always return false. So that's it for today's video. We covered what Frida is, how it works, and how to set it up from scratch. Then we moved to real-world examples, hooking methods, bypassing ADB check logic, modifying app's behavior at runtime, and even using AI to speed up Frida scripting. If you are new to Frida, you should now have a solid foundation and clear understanding of how dynamic instrumentation works on Android. If this video was helpful to you, please like and subscribe, that really supports the channel. And if you have any questions or suggestions, please feel free to comment below. Thank you for watching and see you in next videos.